Chapter 8, Work and Energy. This lecture will help you understand potential energy. Energy is the property that must be transferred to an object in order to perform work on or to heat the object, and can be converted in form but not created or destroyed. Energy produces changes in matter. Energy is also the ability to do work. The effects of energy are observed only when it is being transferred from one place to another, or it is being transformed from one form to another. Both work and energy are measured in joules. When discussing energy, we use the symbol E. Potential energy is energy possessed by a body by virtue of its position relative to others, stresses within itself, electric charge, and other factors. The roller coaster's gravitational potential energy depends on its height above the ground. Springs store energy that can be released at a later time. Potential energy is given the symbol U. Internal potential energy is determined by the nature or condition of the substance. Gasoline, compressed springs, stretched rubber bands, and a drawn bow all store energy and have the potential for doing work. Does a car hoisted for repairs in a service station have increased potential energy relative to the floor? A, yes. B, no. C, sometimes. D, not enough information. Answer is A, yes. And if the car were twice as heavy, its increase in potential energy would be twice as much. The amount of gravitational potential energy possessed by an elevated object is equal to the work done against gravity in raising it. Work done equals the force required to move it upward times the vertical distance moved, or W equals force times delta Y. The upward force when moved a constant velocity is the weight, mg, of the object. So the work done in lifting it through height h is the product W equals mgh. Potential energy is measured from an arbitrarily defined reference level. In that sense, gravitational potential energy can be positive or negative. We really only discuss the change in potential energy. The equation for gravitational potential energy is the weight of the object times the height above a surface. Since weight is mass times the acceleration of gravity, the gravitational potential energy is mgh. Gravitational potential energy only depends on height, not how it got to that height. Gravitational potential energy examples: water in an elevated reservoir, or the elevated ram of a pile driver. In the three examples, a 10-Newton ball is raised to a height of 3 meters by 3 different paths: vertical, up a ramp, and up a set of steps. The gravitational potential energy is the same in all cases. A wrecking ball of mass 200 kilograms is poised 4 meters above a concrete platform, whose top is 2 meters above the ground. With respect to the platform, what is the potential energy of the ball? And with respect to the ground, what is the potential energy of the ball? For a mass of 200 kilograms, 4 meters above the platform, the potential energy is 7,840 joules. For a mass of 200 kilograms, 6 meters above the ground, the potential energy is 11,800 joules.